Now we're going to talk about the transfer of energy between substances. In this particular example, we're going to have a hot metal that we put into a cold cup of water. So first thing that you want to do is think about the transfer of energy. What's warm, what's cold, where's the energy moving? So this hot metal going into the cold water, the hot metal will release its energy, that's exothermic, and the cold water is going to absorb that energy, it's endothermic. Okay, with that, let's go ahead and look at this particular problem. So we're given a metal, it's chromium, and the question asks for what's the specific heat of chromium? It says that you have 15.5 grams. You start at 100 degrees C. So you heat up this metal up to 100 degrees C. If you need to heat up a metal, what you do is you just put it in a hot water bath. And you take the temperature of the water, and that will be the temperature of the metal. You need to let it reach that temperature for at least 10 minutes. So if I got this water up to 100 degrees, I would let the metal boil inside of that water for 10 minutes. And then I know that it would be in thermal equilibrium. So we heated this up to 100 degrees. Then I put that metal into 55.5 grams of water, and the temperature of that water is 16.5 degrees C. Now I have my temperature probe inside this cup with the hot water. Remember, it was initially at 16.5 degrees, and it finally warms up, and then it evens off, comes into thermal equilibrium at 18.9 degrees. So the problem tells us the final temperature is 18.9. Well, thermal equilibrium, I know that's the temperature for both, the final temperature for both the metal and the water. So label everything, and I do it as a table. I'll have, here's my metal, substance 1, here's my water, substance 2. Second thing that we're going to do is write the formula. So I'm going to put down a little recipe list here. Number 1, you want to label everything, okay? If there's so much data, you've got to label it. Step 2, you're going to write the equation. With this, I think this is the hardest step. If you can write the equation, you can do everything else. You're thinking about transfer of energy. So again, the hot metal releases the energy, that cold water absorbs the energy. So the hot metal releasing, that's exothermic, is negative. The energy released by the metal, see that negative, released by the metal, has to equal the energy absorbed, endothermic, positive, absorbed by that water. Now we are going to assume that this is a perfect system, that the calorimeter doesn't absorb any of the energy, that 100% of the energy from that metal goes into the water. Is that true? No, but a lot of problems, they'll make this assumption. So no calorimeter constant. If we did, I just do plus QCal. Okay, next we are going to substitute in the formulas. So substitute the formulas. We are going to have negative Cm delta T, and this is for the metal, equals Cm delta T for the water. I've said this several times in other videos. Oh, be so careful with that negative. You have to treat it mathematically. Students will accidentally, and I'll do it too, forget to carry that negative, and it makes a difference. So treat that negative mathematically, make sure that you carry it. Next, really, is just going to be a plug and chug. We plug in our numbers, and we will solve. I'm going to do that in a different color for you so that you can see it. Okay. We're going to pull it right over here. Negative, specific heat of the metal, that's our unknown. We have 15.5 grams times final temperature, which is 18.9 degrees C, minus initial temperature, 100 degrees C. And I'm going to put that up here as a reminder. T final minus T initial. It's always final minus initial. Very few exceptions to that in chemistry. Final minus initial equals specific heat of water, 4.184 joules divided by gram times degrees C times the mass right here, 55.5 grams. Final temperature, 18.9 degrees C, minus the initial 16.5 degrees C. Okay, now we have a pretty good algebra problem. I'm going to take the time to talk about significant figures as we do this because we change operations a couple of times. Let's look first at order of operations, our subtraction. We've got 100 minus 18.9. Okay, least digit is going to be in the tens place. That's where we truncate. So this is going to give us 81.1. 81.1. I'm going to make a note of that, 81.1. And notice I truncated at the tens place right here. That means I have 3 sig figs carrying forward. Okay, so I'll have 3 sig figs times 3 sig figs. Over here, let's look at this one. We've got 18.9 minus 16.5. Again, truncate at the tens place. So we are going to have a 2.4. Ooh, 2 sig figs. We're going to carry that forward with 2 sig figs. Okay, now we can do the rest of the math. So I'm going to take 15.5 times, ooh, check this out, 18.9 minus 100, that's negative. That's going to be a negative 81.1. And when we do that, I left some little notes up here so I won't have to use my calculator. We have the specific heat C. Negative times negative becomes a positive, so important. And we get 1,257.05. So my 3 sig figs times 3 sig figs, I'm just going to make a note, we're at 3 sig figs, okay? That as I'm going forward doing the rest of this math, I have 3 sig figs from this number. Equals, now we take 4.184 times 55.5 times 2.4, it's going to be positive, and our value for that is 557.31. Now in this one, it's got 2 sig figs. Okay, I'm just going to make a little note to myself. We had 3 sig figs, 2 sig figs, so this is going to be 2 sig figs. Let's take just a second and look at units. I've got gram times degree C. I might write this in a different color for you so you can follow the units because the units will tell you if you do it right or not. So I end up with gram times degree C. Great. Now over here, joule divided by gram times degree C times gram. Grams cancel. And then multiply that by degree C. The degree C cancels, which means I have joules right there. Okay, now we're going to solve it. And you know how to solve this. We're just going to divide both sides by the 1,257.05. 1,257.05. And remember, the reason why I didn't truncate already is because if you're doing the same family of operations, you don't have to truncate until the very end. So I multiplied and now I'm dividing is at the very end. If this was 3 sig figs and that's 2, I'll truncate to 2 sig figs. So when we divide this, we are going to get the specific heat equals 0.44. Now look at the unit. So I divided by gram times degree C. Gram times degree C. Ah, cool, check it out. It is joules divided by gram times degree C. That's our unit for specific heat capacity. Awesome. I looked up chromium, its actual specific heat is 0.46. So we were really close. Okay. So a couple of things to point out on this. Be careful on the sign. I cannot stress that enough for as many times as I've made the mistake or I've seen students make the mistake. Be careful on your sig figs as well, that you're just making a note, quickly look and count sig figs that you're tracking with that. Okay, and then units always. Units will confirm if you did it correctly. Okay, oh, it looks so cool. Look at what you're doing. Feel good. Awesome. Good work.